Welcome back to the History of Mathematics. We are continuing our work in Chapter 3 of Makers of Mathematics on Euclid and Apollonius. In our last video, we talked about Euclid's proof that there are infinitely many prime numbers, and in this video, we're going to go over the so-called Euclidean algorithm. So this Euclidean algorithm is a procedure for finding the greatest common divisor of two numbers. And of course, as the name implies, the greatest common divisor of two numbers is the largest number that will divide into both of them evenly. Okay, so in this context, when we say one number divides another number, we mean that it divides it with no remainder. So we'll just get started here with an example, and we will use the Euclidean algorithm to compute the GCD of 45 and 70. So here's what we do. We start like this. So I need to find the quotient when I take 70 and divide it by 45. So it goes in one time, 45 goes in one time with a remainder of 30. So you're always finding the quotient and the remainder, and your remainder will always be a positive integer, or I guess I should say it will always be a non-negative integer. The smallest remainder you could have is 0. Okay. Now, in the next step, we take 45 and we find the quotient and remainder when 45 is divided by 30. So 45 equals 30 plus 15. And then we apply that one more time. 30 equals 2 times 15 plus 0. Okay, so you'll notice that each time what we do is we kind of shift things down like this. So in our first step, we're taking 70 divided by 45 and finding the quotient and remainder. In the next step, we're taking 45 divided by 30 and finding the quotient and remainder. And then we kind of keep sliding everything down. So the last step, we are taking 30 divided by 15 and finding the quotient and the remainder. And of course, you stop this process when you get a remainder of 0. Now, the GCD is actually this guy right here. So in other words, the GCD is the last non-zero remainder that you get when you apply this process. Okay, so from our work here, we can see that the GCD of 45 and 75 is equal to 15. So 15 is the largest number that will divide both of those evenly. Okay, one quick application of this is once you know the greatest common divisor, there's an algorithm you can apply to figure out the least common multiple. And now the least common multiple is the smallest number that both 45 and 75 will divide into evenly. And the way you can find your least common multiple is to do this. You take the product of the two numbers that you're looking to find the LCM for, and you divide that product by the GCD of those two numbers. So, since we know what that GCD is, in this case it's 15. And let me see, we can do a quick calculation here. I think I'm getting 225. So 225 is the smallest number that both 45 and 75 will divide into evenly. Let me just pull out a calculator here and check my math. Okay, so I'm going to do 225 divided by 45. Okay, so 225 is 5 times 45. I'll do 225 divided by 75. So 225 is 3 times 75. Okay, so both of these numbers, 45 and 75, they both go into 225 evenly, and this is the smallest number with that property. Okay, one other application that I'd like to show you of the Euclidean algorithm. Finding the LCM uses the result that we get from the Euclidean algorithm, but it doesn't really use the steps that we get from the Euclidean algorithm. So here's what I want to do. I want to find integers x and y so that 45x plus 75y equals 15. So this number right here on the right hand side, this number has to be the GCD or a multiple of the GCD for you to be able to do this process. Okay, now to find x and y, what I'm going to do is I'm going to rewrite my steps from the Euclidean algorithm. Just going to copy those down again so I got them for reference. Okay, now I don't actually need this last row, so I'll just kind of X that out. Okay, now what I do is I want to write every line in terms of 45 and 75. Okay, so this second line is in terms of 45 and 30. So what I want to do is I want to use the first line to write 30 in terms of 45 and 75, and that's pretty easy. You can kind of quote-unquote solve for 30. By subtracting over this term. And then we substitute that into this second line. So the second line becomes 45 equals not 1 times 30, but 1 times this expression, plus 15. Okay, so 2 times 45 minus 1 times 75 equals 15. So I just moved these terms over to the left-hand side and combined like terms with the 45 and the 75. Okay, so this is the value of x that I should use, and this is the value of y that I should use to make this happen. So I can always write my GCD as a linear combination of the two numbers involved, and I can find the coefficients that I need for my linear combination by taking every line of the Euclidean algorithm and going down to the next line. And I keep on doing that until I reach the next to last line. Remember, we don't need to use this right here. This part isn't going to help us. We can just stop when we get to here. So that's the basics of the Euclidean algorithm.